Good morning, it's Engineer Heather there. I warmly welcome all of you guys on my channel Complex World. So, before going to start our video, like, subscribe, and share this channel with friends, family, and students and start learning engineering, science, and technology with us. So, today we are going to solve a numerical problem on economic dispatch problem. So, this is the most important topic for those who are doing their research work in power system analysis and economic dispatch and load flow analysis. So this is the problem of our today's lecture. So before going to start our problem, it's my request to all of you guys to like, subscribe, and share this channel with your friend, family, and students. So let's start the problem. You can see on your screen that the question on the problem is given. With the four options, you have to select the right option for this problem. By calculating the value of Pg1 and Pg2 by using this data, four options are given, A, B, C, D. Okay, first of all, analyze the problem. So you are given with the question and you are supposed to find the value of Pg1 and Pg2. Four options are given here and you have to select the right option for your problem. So the incremental fuel cost of a generator G1 and G2 are given by. So you are given with the two equations. These are the equation for incremental cost. IC1 and IC2 are the incremental cost for generator 1 and generator number 2. So the first equation IC1 equals to 25 plus 0.2 Pg1. Pg1 means the power generated by the generator number 1 and Pg2 means the power which is generated by the generator number 2. So the second equation IC2 equals to 32 plus 0.2 Pg2. So you are given with the two equations which are the incremental fuel cost equation and you are supposed to find the values for Pg1 and Pg2 where Pg1 and Pg2 are the power generated by the unit. The economical allocation for total load is 250. Okay, so the total load is given 250 megawatts. So the power generated by the generator number 1 and generator number 2 is 250 megawatts. So always remember to write the equation which is a total load equation which is given by Pg1 plus Pg2 equals to 250 megawatt. This is my equation number 1. So for equation number 2 for Pg1 and Pg2, compare these two incremental cost IC1 and IC2. So comparing IC1 equals to IC2. Okay, put the values of IC1 and IC2 in this equation. 25 plus 0.2 Pg1. 25 plus 0.2 Pg1 equals to 32 plus 0.2 Pg2. Okay, now comparing these two equations, you will get another equation for Pg1 and Pg2. Okay, now solve these two equations for Pg1 and Pg2. Take Pg1 and Pg2 at one side and the constant values on the other side. You will get 0.2 Pg1 minus 0.2 Pg2 equals to 32 minus 25. Okay, take the 0.2 common from this side. You will get 0.2 Pg1 minus Pg2 equals to 32 minus 25. You will get the answer 7. Okay, now divide this 0.2 with the 7. You will get the answer on the second side. Pg1 minus Pg2 equals to 7 divided by 0.2. Okay, when you divide, you will get Pg1 minus Pg2 equals to 35. This is my second equation. So the first equation is Pg1 plus Pg2 equals to 250. This was my first equation. You can see here, this was my first equation. So now compare these two equations to get your answer for Pg1 and Pg2. Okay, how to get the answer for Pg1 and Pg2? You can just simply add these two equations. You will get these two equations will cancelize. You will get 2 Pg1 equals to 250 plus 35. Add these two numbers, you will get 250, 35, you will get 285. Okay, divide with the 2. Okay, when you divide 285 with 2, you will get the answer 142.5 megawatt for Pg1. Pg1 power generated by generator number 1 is 142.5 megawatt. Okay, now put this value in any of these equations to get the answer for Pg2. Okay, Pg1 minus Pg2 equals to 35. Use this value in at this side. You will get 142.5 minus Pg2 equals to 35. Take this to the other side. Minus Pg2 equals to 35 minus 142.5 minus Pg2 equals to, okay, when you subtract these two numbers you will get the answer 107.5. okay, these two minus will cancel out and you will get the answer Pg2 equals to 107.5. so this is the answer for power generated by generator number 2, which is 107.5 megawatt, and this is the answer of power generated by the generator number 1, which is 142.5 megawatt. okay, now look at the numerical again. You are supposed to select any one option which is the correct option from all these options by you analyzing this problem. So the option number A is the correct option for this problem. Pg1 142.5 and Pg2 is 107.5. all these options are incorrect. Option number A is a correct option for this question. Now come to the problem number 2, in which a lossless power system has to serve a load of 250 megawatt. So in this case you have the total load of 250 megawatt. Two generators G1 and G2 are connected, generating the power, and you have to find out the value of power generated by G1 and G2 in this case, and you are given with the incremental equations, which is C1 Pg1 equals to Pg1 plus 0.055 Pg1 square, and for incremental equation number 2 for generator number 2, 3 Pg2 plus 0.3 Pg2 square. You have to find the value of Pg1 and Pg2 for this case if the total load is 250 megawatt. So this problem is just like same as the previous problem. In this one you have to derivate C1 and C2 with respect to Pg1 and Pg2 to get your equations. Okay, I am going to derivate the equation C1 with respect to Pg1, dC1 divided by dPg1. You will get the answer 1 plus when you derivate this equation you will get the answer 1 plus, okay, derivate this ones, so you will get 0.11 Pg1. so this is my first equation. Okay, same is the case with the second equation. Derivate C2 with respect to Pg2, dC2 derivate dPg2 equals to, you will get the answer 3 plus, you will get 0.06 Pg2, and this is my second equation. Okay, now we have the equation Pg for dC1 and dC2, which is derivative of, okay, next case is the comparing these two equations. dC1 over dPg1 equals to dC2 over dPg2. Now put the value of these two equations by comparing equation number 1 and equation number 2. Put this value 1 plus 0.11 Pg1 equals to 3 plus 0.06 Pg2. Okay, now take the G1 and G2 at one side and the constant values on the other side. You will get 0.11 Pg1 minus 0.06 Pg2 equals to 3 minus 1. 0.11 Pg1 minus 0.06 Pg2 equals to 2. So this is my first equation for calculation of G1 and G2. Okay, for second equation we have in the question that the total is Pg1 plus Pg2 equals to 250 megawatt. Okay, my second equation will become Pg1 plus Pg2 equals to 250 megawatt. So this will be my second equation for calculation of Pg1 and Pg2. Now use these two equations to calculate the value of Pg1 and Pg2. You can solve these two equations by using the linear algebra techniques, which is a Cramer rule or any rule, or comparing the equations by using the comparing coefficient method or any method which is used to solve the linear equation. So when you compare these two equations you will get the answer for your problem, which is Pg1 equals to and Pg2 equals to, you will get in megawatt. So solve these two equations, which are the linear equation, to get your answer Pg1 and Pg2.